There's different ways to scale up the number of qubits. We haven't talked about it yet, but to reach a fault-tolerant quantum computer and have high confidence of useful applications, you need to have likely millions or tens of millions or even hundreds of millions of physical qubits. It depends on the quality factor of the qubits, their lifetimes, and the fidelity of the gates. But certainly one chip is not likely to offer a durable commercial value of a quantum computer. And so there's different ways to scale up. The single chip dies have reached almost close to a limit. I'd say you're probably at around 1,000 qubits in superconducting or in trapped ions or neutral atoms. You can have multiple dies on a same chip through a carrier wafer. That'll give you a factor of 4 to 8. So you can get up to, perhaps 1,000, 2,000 qubits. But to get up to the millions, you're really going to need to network. And so just like today's classical computers have networks of CPUs and GPUs, quantum computers will also be networked coherently via entanglement of hundreds or thousands of quantum processor units, QPUs. And until you have error correction and a large number of QPUs, I would say we don't truly have a useful quantum computer. But we're making great progress. This year, we've seen exciting results from a number of companies and startups, QEra and Google, on the progress of showing the progress towards fault tolerance. So showing actually logical qubits, multiple logical qubits, reaching that threshold where actually as you increase the size, the number of qubits on a chip, you can drive down the error rate, which is a key threshold for error correction. So we'll see that continuing to develop, but it's awesome to see the progress. And now is the time as companies are working to scale up and to actually start networking.